Hello everybody and welcome to the Power Control podcast. This time we're talking about how UPS systems can be modified to comply with Central Power Supply System standards, BS EN50171. This standard specifies the general requirements for CPSS for an independent energy supply to essential life safety equipment. With me to discuss this topic is Stefania Ceccarini, Product Specialist at Borri SPA, Graham Tucker, Sales Director at Power Control, and John Sams, Regional Sales Manager at Power Control. Graham, can you start us off with an overview of the standard?
Thank you very much, Kate. Yeah, so we'll be talking about here UPS is to work as central power supply systems to comply with EN50171. So this is life safety systems for emergency battery backup systems. So this really is a UPS product that is being used in the traditional central battery system market, which has become a lot more prevalent in the last couple of years, mainly because of the technological advancement of UPS systems has enabled them to run as a more efficient system, a more cost-effective system over a traditional central battery system that's perhaps comprised of an inverter and a separate rectifier assembly. So this covers emergency backup systems, maybe maintained or non-maintained systems as well, where they interface within the emergency lighting system of a building, maybe an existing system as well, so that the emergency lighting luminaries can be centrally controlled, also from the UPS. And of course, to comply with the standard BS EN50171 as well. So the technology is very similar to UPS system, as it always has been traditionally, but there are certain compliances that the UPS system has to be modified to in order to meet these standards and work in this application as well. So we're going to talk about the technology and the standards as well. Maybe John, you can perhaps just give us a bit of a background into the standards in the UK for a central battery system and how a UPS is now being used in that situation.
Yeah, thank you very much, Graham. Thanks, Kate. So Centralized Battery Systems was the former name for the product, and they were primarily used for emergency lighting, which is a life-critical service for the evacuation of buildings under any emergency situation. What we saw with the advent of 50171, that this allowed the same product to be used to support other essential service loads, such as security, maybe even CCTV is added to that, along with smoke extracts, pressurization systems, and misting systems is another common thing that we're seeing now, along with lifts. So no problem with all these applications. All those motors can incorporate soft start via their VSDs, make them very smooth and makes a very efficient, compact solution. The other things that we've seen is that there's more pressure on removing fossil fuels from city centres under any circumstances, and so we're getting requested for all manner of 50171 solutions for supporting entire multi-storey buildings. And if we break the loads down, there's good possibilities we can cover that, but we have to think of the loads at the same time whilst we're doing that.
It's interesting, John, you say about the lifts and sort of emergency evacuation systems in cities particular, because we've seen a lot of requirements over the last couple of years for central battery systems to be used in place of generators for the secondary supply for lifts and emergency evacuation.
Absolutely.
Where a generator would have perhaps traditionally gone on top of a roof. People don't want a generator up there, particularly don't want diesel up there and things like that, and having a central battery system is much more preferred.
Yeah, there will always be applications for diesels in my mind, or generating equipment, whether we change the fuel maybe to hydrogen at some stage or gas, which are burning clean. But the added complications with generation is vibration, noise, smoke. You know, these make them difficult to accommodate, especially when there's high pressure on real estate in city centres. We're trying to keep the noise levels down as low as possible. And then there's space attributed to that. And with the recent government legislation, generators are required to have particle filtering and fume reductions when they're used in the city centres, even for emergencies. The feeling is that there's going to be further pressure to remove them from sites. But I still think there'll be applications going forward. The other thing is that electronics, the centralized battery system has reduced significantly in size, become very much more efficient. Battery technology is understood and widely used throughout buildings for IT loads as well as essential services. So yeah, I think the future's bright. We're certainly propagating these solutions into the marketplace with the presentations, the seminars, which will be accredited in the coming weeks, and we'll be rolling those out through the building services design consultancies in the UK. But it's very important to understand technically how they work so that you don't get into problems once they're installed. And we've had great support from Stefania in particular. The regulations are quite tight, understandably. This is essential service applications. So the consequences of it going wrong can be very serious indeed. And we need to ensure we've got the right technical solution, which is fully compliant with the specifications in place.
Yeah, that's right. So obviously the technology within a standard UPS product suits the central battery system very well because it's a lot more advanced than perhaps traditional central battery systems. However, like you say, John, there is additional regulations they need to meet. Additional modifications are required on the UPS. In fact, it's in most cases it is an actual different product to the normal UPS. So perhaps maybe Stefania, we can ask you what are the differences and the modifications that need to go into a sort of a normal UPS system in order for it to fulfill the application of a central battery system.
Yes, thanks, Graham. Thanks, John, and thanks, Kate. First of all, I would like to say that Borri, as a UPS manufacturer, is part and contributes to basically all national industry associations and committees whose scope is to set worldwide UPS industry standards. And I would like to emphasize how much industry standards and the importance of industry standards as these allow end users and customers to really be able to compare products from different manufacturers against the same performance and safety targets. With this in mind, we participated also this program, so the project standard EN50171, which date back to 2001 actually, and it was first released by the European Electrical Committee UPS working group. As you mentioned, Graham, to be compliant with the standard, a regular UPS must be sort of modified in order to include some specific features. I would say that the most important ones are the permanent overload capability set to 120%. As you know, a regular UPS would bear 100% of its rated power, whereas a CPS must have an extended overall capability by 20%. And then the second most important feature is that a CPS shall not be damaged by a battery polarity reversal caused by a wrong connection. So it must be definitely protected from this kind of failure. Then batteries must be sized to an operating temperature of 25 degrees and must be 10 years life expectancy. Then a deep discharge protection must be included. Deep discharge protection means that it might mean two things actually. One is the end of discharge voltage must be adjusted according to the actual discharging current, where the lower the discharging current, the highest the end of discharge voltage must be set. And then the UPS must be, or CPS must be protected by a full discharge. That means that under no circumstances the battery can be fully discharged. And in turn, that means that the UPS must disconnect the battery actually before reaching the full discharge. So before fully discharging their capacity. These are basically the main differences or main prescriptions that a CPS must undergo when it has to be applied as a CPS or central power supply.
Thanks, Stefania. Yeah, for going through the technical side of that as well, and what it really means for the end client and the customer and the contractor as well is a more cost-effective solution. Being able to use a standard and developed high-efficiency UPS product now in the central battery system application will be much more cost-effective than perhaps the traditional, more bespoke inverter system. So there are a lot of benefits for obviously the end user and the contractor as well. And just reiterating as well, John, some of the applications we've installed recently using particularly the Borri products. We've mentioned earlier about the lift system, the secondary supplies going into emergency evacuation lifts where the UPS has been running, keeping the batteries charged, kicking in upon an emergency. So being there ready as a secondary supply to kick in as well. Very similar for a traditional emergency lighting system, a building emergency lighting system, for example, that the UPS will then kick in once the mains has failed, so kicking in as a secondary supply. So it works very similar as a traditional UPS. A traditional UPS, however, runs in line filtering the mode normally, when a lot of these applications, it comes in either kicking in via a contactor on the output, or whether the UPS is configured to kick in as a non-maintained system. But also, because it's based on traditional UPS technology, it can run as a maintained system, whereas it's always in line filtering as well, supporting the emergency systems. So there are various different applications for that as well. Of course, hospital lighting in theatres, these systems can be used in as well. John, we've done some projects recently in sports grounds, haven't we?
Yep.
With these types of systems, maybe sort of run us through the type of application that these systems were used in.
Well, the very good thing about centralized battery systems is that they are used across all applications. So they're used in data centers. We're bidding, good values of solutions for data centers themselves for the centralized power supply systems. That's covering the emergency lighting and any other essential services in there. We're also bidding them for stadiums. As you know, we've supplied a few for stadiums, theatres, in hospitals as well. So across all applications, buildings, general commercial, stores, everybody needs this support when there's an emergency in case of loss of power. They need to have a continuous, reliable supply, and that's what we're achieving. And we're seeing that, you know, the more we educate the consultant engineers in the marketplace, the more inquiries we're drawing, predominantly because of the pressure to reduce the size, cost, and provide the right solution for the applications they're addressing. So we're always open to do that. There are some other specific standards in the UK which we have to be aware of. BS 9999, 9991, which many of our designers are familiar with already, and they might want to understand how 50171 fits into their building designs, and we can run through that with them to give them the right application. So I think, you know, there's a very wide market we're addressing, and every day there's variations on what they're needing to achieve from the centralized battery systems. NiCad batteries is another option which can extend the life and reduce the total cost of ownership still further, achieving maybe 20 years in service. And by having a centralized system, you're much more flexible to adjusting the type of battery which you're using to make sure it meets the performance criteria for the site. So yeah, it's exciting times, and I just see that the future is going to continue to drive more and more of these applications.
Yeah, it's certainly been interesting to see, especially over the last 5 years, how standard UPS technology and the standard UPS product that has these additional sort of modifications that Stefania's been talking about is now used in these different applications. Say not just the EN50171 regs, but also maybe emergency supply systems that fall outside these regs. We were talking about earlier, John, sort of extraction devices and mist control systems where you have pumps and jockey pumps, and there's certain regulations involved in them that secondary supply is needed as well. So UPS I mean, we've installed many UPSs over the years in those systems, supplying sort of mist control systems and backup extraction fans as well. Again, considerations needed for those applications with, depending on how the fans are controlled, the inverter drives, the direct online start currents. But again, we've got a lot of experience in helping design the UPS and configure the UPS in order to be able to take those different inrush currents for those circuits as well. So the variety of applications outside the traditional UPS IT application we've been using, particularly in sort of sports stadiums, etc. We've done a number of projects this year backing up the sort of emergency lighting and interior lighting of stadiums, and many throughout the country. We've installed systems and maintained that there to keep backup going if there's a power failure and people need to obviously evacuate as well. So yeah. Thanks for your input, John, and Stefania as well, and talking us through the technology. Is there anything you want to add, Stefania?
Yeah, I think maybe you know, going forward, there might be an increase in power rating for centralized battery systems. I don't know how many modules we can put in parallel, Stefania.
As of today, the ECS range at Borri, according to our experience, is covering the vast majority of the requests. We span from 10 kVA up to 160, which is the, I would say, usual power range. Yeah, but yes, of course, definitely. Then any kind of course, in rush current is an aspect, is a very important aspect to be considered when sizing any UPS for any application, including CPS systems. And as you mentioned before, emergency lighting can show and exhibit quite a high inrush current sometimes. So the solution to the problem is just to size either a parallel system which can grow in power, or to size with a bigger UPS, bigger modified UPS compliant to the standard. So, in our portfolio, we are featuring solutions up to several megawatts. So no problem with that should the application grow more and more in the future.
For me, as an application, I always just, the lifts are available with regenerative power or not. So the way it works, Graham, is that the lift is powered to take people up the building, and then when it's descending, it's generating power which is passed back onto the grid. And the reason that the lift suppliers like to do this is because it's offset against the power that they use.
Yeah.
It makes it look super efficient. But
Yeah.
the problem is dealing with that. So
yeah, definitely.
Well, so I think for us at the moment, the UPS is not in line. So if it's backing up a lift, as long as if it's as a backup supply. So normally when the lift's working under normal situation, it's using mains power, and then it regenerative goes back to the grid. There is a changeover switch on the output of the UPS and the mains. So when the mains is lost, the changeover switch goes to the UPS output, and then the UPS is running on, is supporting under emergency supply the lift. When I think then the control panel for the lift stops the regenerative load. So I think that's how we've done it before. So when it's on when the UPS is acting as the supply, as the secondary supply, then the lift doesn't regen.
Yeah, that's an excellent solution, I would say.
But the way I've addressed it, Graham, is I've said that the
Borri will do it.
no, the firefighting lift must not be regenerative. All the other lifts can be regenerative, but the firefighting lift must not be, or the load that's on the lift that is on the CBS, it must not be. The second thing is, wherever else I've worked, is for our information, is that the if it's regenerative and it's on a distribution panel on the output of the CBS, then all the loads on that distribution panel see the regenerative power, and it's normally lost across the composite loads, the lighting and everything. It becomes a no problem.
You're right, definitely. As long as the regenerative load is not the one and only load of the UPS, that's usually fine.
Good. Okay. But I like to know exactly what they are, but there are solutions out there where they switch in resistor banks to dissipate the energy that's being pushed back onto the load. And of course, that might be an application where it's existing, but most of the projects we're on a new build. So we just say, we don't want regenerative lifts being on the output of the centralized power supply system.
Because I think under the EN50171, it applies for a backup supply to kick in, whereas normally UPS is always running, always filtering. So UPS does not kick in; it's continuously supplies. So I think in most lifts, the UPS will have to be sort of offline, or sometimes I guess we could do it through the sort of the eco mode of the UPS or the static switch. Can the regen load go back through the static switch, Stefania?
Yes, definitely, yes. As John mentioned earlier, as long as while on battery, so with no mains available, the load is not regenerating, then it's totally fine to back it up with a UPS or a CPS. No problem.
Very good. That's good to know. Thank you.
Thank you.
Thank you both.
Thank you, Graham.
No worries. Thanks for listening, everybody.